already talked about some of the things. We talked about definition of value and so on. And we also have discussed two of these domains. So we talked about the customer domain and how important it is to define and understand who your customer is. It all falls apart if you don't have defined a customer. You will make a product that appeals to nobody. If you try to please everyone, nobody will be super happy because you have to make too many compromises, and you will end up creating a product that doesn't have especially high functionality for someone's specific needs. And usually over time, your product will become less and less attractive because the others will compete by making nicer things. But, for some time you can follow that game. But it's not how you make a high-value product or innovate against known and unknown customer preferences. So for that kind of a product strategy, you should take another course. It's much more about optimization of supply chains. So that's the first domain, customer identity and definition. The next domain was value. Customer value is the satisfaction of customer needs in proportion to use of customer resources. There are other definitions, like utility minus price minus cost. That's from a book called Blue Ocean Strategy. So utility is more or less satisfaction of needs. Price is what you pay. Cost is something that comes after. And you can have a wide definition of cost. So you can have time that is wasted, effort and so on into cost. But if you do it mathematically, like something minus something, you get the added value. And that we use also. Today we're going to look at functions. And one thing that is good with functions, that in contrast to these needs, which are usually fluffy statements, with functions you can measure some functions. Needs are difficult to measure. Functions usually have a performance dimension that could be quantified. So you can actually say, if you do it with my service, you save half of the time you use for doing this job, right? And then you multiply that with the salary and say, there's an economic benefit here. And that economic benefit you can use to calculate a business case, an added value. The added value. You make this much, cost this much. Functions are the outcome of usage of the product and service. There's only one way to satisfy customer needs, and that's by providing functions. So now we're going to define the product itself, or you can call it the utility carrier. Whatever carrier is, the functions that resolve customer needs. Functional thinking is not difficult. It's not rocket surgery. It's really simple, but you have to be very disciplined. And that's why we're going to have a workshop specifically about this, because it's so easy to fall into habitual thinking and instinctual definition of functions, but it doesn't work. You have to be super strict, and you have to use the syntax. So the watch tells the time. It's a function provider, the watch. The function is tell time. The function receiver is the user here. So the main function, telling time, the watch conveys state. Noun, verb, noun. One thing in each statement, no extra fuzziness. The main functions are the reason we buy the watch. If it doesn't tell time, we wouldn't buy it. Then we have added functions, additional ones, same syntax. The window shows the day. It adds a little bit extra. It has some value, but it's not the reason we bought it in the first place. And then we have unwanted functions. Almost all products and services have unwanted functions. So they have negative effect for the user or maybe for the environment. So the car emits exhaust, right? If you use fossil fuel, you burn it, there is some exhaust. It's a negative function. It's a result of use, but it decreases value. And if we can reduce those unwanted functions, it also becomes a better product. And often, if the negative result of use is for the user, like I fuel the car, I clean the car, the user service the car. So the user is the function provider. for the system, it adds to effort, time consumption, money consumption. It's on the denominator of the value equation. That means that there are some strategies for increasing value. We increase the performance of the main functions. We add additional function or increase in performance on them. And then we reduce or eliminate the unwanted function. But then we have support functions. That's everything that is needed in the system to make it work, but it doesn't do anything specifically for the user. We could eliminate those. So for a car, the gearbox connects the wheels to the engine and so on. Why do we want to eliminate those if we can? All these support functions add to the cost of the product. So if all else equal, if you have a complicated mechanical watch like the one I'm wearing today, you can just put in an electrical system that the user doesn't have to wind the watch. If you eliminate that, you can take away lots of gears and other support functions in it and make it cheaper. So it should be higher value for me. Of course, that goes in conflict with conveying status normally, because if it's expensive and complicated, those that get impressed by these things think it's a higher performance, right? It's higher performance on my status needs. So, for example, what is the function of a hairdryer? Hairdryer dries the hair. Yes, it's fairly straightforward. So that is an expression of the function in relation to the value it has for the user. But you could also express the function of a hairdryer in physical terms. The heat evaporates water molecules, right? The airstream forms the hair and so on. So it's a physical domain. And then you can also have other like chemical or things like that. Usually it's the best to go for the value, like what is it doing for the user? Because you can connect it to the need satisfaction. But sometimes you might need to use other language. Why do we go through the difficult work of breaking everything down to small statements that are really strict? And it seems like almost you're punishing yourself or something like that. But the thing is, it is very useful because, first of all, the first use for functional statements when working with strict definition of results of use is that you can compare what your product is doing to the other options that the customer will have. So that's the first use. A second use of functions is that this language is really creating a bridge between the fluffy statements that the customers have about their needs, that we sorted and organized and really driven it back to needs, although their statements are all over the domains, into something that's very precise. It's exactly these things that happen, and we're exactly this good at it with the solution. And we can take another solution and get this much better, and we can compare the cost for the two solutions, how much difference is the value for the customer, and we connect it all the way. This language, the hairdryer dries the hair, and everybody can understand it. Often, if you work in a company with innovation, you have cross-functional teams. You have people from marketing, you have people from engineering, R&D, and they can misunderstand each other quite often. If you use the functional specification, say, yeah, but the hairdryer also has the heating. The heating damaged the hair. Okay, let's agree on that. That is not good. So can we work on how to reduce that unwanted function? So it creates a common language that is not filled with technical words. You just clearly specify exactly what's happening. And everybody can understand it. They will not misunderstand each other. They can talk and they can meet on this abstract bridge that connects the technical domain of the company with the value domain of the customers. So the third one would be that if you state the functions as function provider and the activity or verb, and then the function receiver, you can just draw it up, right? Starting with the value-adding functions, those functions will be directly connected to the user, and the function providing subsystem is connected to the user with an active verb on the arrow. Similarly, the unwanted function is connected, in this case also to the user. Then you can add the support functions. Here the subsystems are both function providers and function receivers. All the arrows should be one way, as the flow in the opposite direction would mean that there is another function, which might happen sometimes. Drawing this is actually a good test of your functional specifications. You should be able to draw the function model directly from the syntax, and we can see visually that the support functions do not contribute to value, because they are not touching the user. But unwanted functions are touching the users, or sometimes the environment in some sense. Okay, so going on now, I promised you a fourth reason for using functions. Most of the time, when we increase value, we also increase cost. So we perform better, we add more functions and so on. And that's why we want to be very specific with who the customer is and exactly what is their needs. Because then we can sometimes pull these apart. If you know exactly what is important, you can make choices that add value that doesn't cost a lot. And you can remove things that cost a lot because they are not so important for the customer. Sometimes you can charge an even higher price, sometimes not. But anyway, you disconnect competition with increased cost. That's the connection you want to break. If you can quantify functions, and you can quantify some of them, maybe not all, you will see in an example. Of those quantified, there's a few that actually is directly connected to economic value for the customer. You can say that our copy machine is 3 times faster than the one you're using today. And you make copies 100 hours per month, and that will go down to 30. And then you have 70 man hours saved every month, and you put that to $100 each. That's $7,000. And the machine only costs $3,000. You will make the money back in 2 weeks. Is that really a nice deal for you guys? So we can simulate our different choices and make informed decisions in our product development process. Not just saying that what the customers like, we go there with a prototype, they like it, okay, we make it, and maybe they don't buy it. And we can do that before we make anything. So, contrast to some models like design thinking, we will know that the product or service is first of all something the customer reasonably willing to pay for, and we can actually do it and make sure that it's profitable for us as well. So just to summarize, first of all, we link with functions the value the product generates for a specific customer. Another part is that it gives all of us that work from different parts of the company a specific syntax that is very clear. We can talk the same language. We can also validate if our chances with this product to win in the market are good enough before we launch it. So we can see that when we come out here in the options for the customer, we will look like this. And we also can prepare arguments why we are better that we can use in our sales pitch, of course benchmarked. And then we can simulate the profitability of different alternatives. And maybe we will not be profitable with anything that we can make that could compete. And then we know that. We do something else instead.